In this lesson, we want to review solving absolute value inequalities. So in the last lesson, we talked about solving absolute value equations. In this lesson, we're just going to go one step further and talk about solving absolute value inequalities. Now, before we kind of jump into some problems, let's just take a moment here and think about absolute value as a concept. So if I asked you for the absolute value of something like the number 5, what am I asking you for? Remember, the absolute value of a number is the distance from 0 to that number on the number line. So if I want to know the absolute value of 5, I'm asking how far away is 5 from 0 on the number line? We know with any positive number, it's just the number, right? So 5 would be 5 units away from 0, and we can show that it's 1, 2, 3, 4, 5, right? And it doesn't matter that I started at 0 and went to 5. I could start at 5 and go to 0. We're not measuring anything to do with direction. We're measuring the distance, okay? That's what we're focused on. So the absolute value of 5 would just be 5. The absolute value of, again, any positive number is just the number. So if I wanted the absolute value of, let's say, 8, it's just 8. If I wanted the absolute value of 1 million, it's just 1 million, right? So on and so forth. Now, when we work with absolute value, we've got to be aware of some of the restrictions or things that happen when we take the absolute value of a number. If I take the absolute value of a negative, I end up with a positive, right? So the absolute value of negative 5 would be what? Let's go to negative 5 on the number line, and I'm also 5 units away from 0. So I would go 1, 2, 3, 4, 5 units to get to 0. So this answer here is also 5, right? So I took the absolute value of something that's negative, and I got a positive. Because I'm measuring a distance with absolute value, I can never get a negative result, okay? You can think about distance as it relates to you driving in a car. Let's say you want to go to the grocery store. You can either get in your car and decide not to go, right? You just play some tunes in the car, and then you get lazy and decide, hey, I'm not going today. Or you can go some positive amount, right? But you can never go a negative distance. The only thing you can do besides getting a positive result is you can get 0 as a result, okay? If I took the absolute value of 0, I would get 0. And that's because 0 is 0 units away from itself on the number line. So the main thing to understand here is that the absolute value operation is always going to give you a result that is non-negative. So 0 or positive, okay? Very important to understand that because it will come up later on in the lesson. Now, we also want to think about one other thing here. I want you to notice that 5 and negative 5 have the same absolute value, right? If I did 8 and negative 8, those would also have the same absolute value. Okay, so numbers like these, 5 and negative 5, or 8 and negative 8, or 2 million and negative 2 million, these are known as opposites, okay? They're going to have the same absolute value, okay, because they're the same distance away from 0, but they lie on opposite sides of the number line. One's on the negative side, one's on the positive side, so we call them opposites. All right, so now that we understand the concept of absolute value, let's think a little bit about how we can solve an absolute value inequality. We're just going to start with some very simple examples here, and then we'll get into some more challenging material. So we're going to start with the absolute value of x is greater than 5. So using our understanding of absolute value, what am I asking for? What can I plug in for x here that would satisfy the inequality? Well, remember, if I'm taking the absolute value of something, I want to know the distance from that to 0 on the number line. The absolute value of x is greater than 5 is saying that x can be any value whose distance from 0 is greater than 5. So to find this, I could start at 0, and I could go 5 units to the right, and I could shade from 5 on, but 5 wouldn't be included because it's got to be strictly greater than 5. So I'll put a parenthesis at 5, or you can use an open circle if you want, if that's what you're doing in your class. And I want to shade everything to the right here because that would be part of my solution, right? So if I plugged in a 6 there, absolute value of 6 is 6. 6 would be greater than 5. That's true, okay? So that would work. If I plugged in an 8, the absolute value of 8 is 8. 8 is greater than 5. That's true. So any number larger than 5 would work. That's pretty obvious. Everybody gets that. But also, I've got to look in the other direction of 0. Because again, when we think about absolute value, it's a distance. So I can also travel to the left. I can go 1, 2, 3, 4, 5 units here. So anything less than negative 5 would work as well. Negative 5 does not work. So I'm going to put a parenthesis there. And again, you can use an open circle if that's what you're doing. And then I would shade everything to the left here. And then we could try some numbers out in this range. Let's say we picked negative 7. So we plug in a negative 7 for x. The absolute value of negative 7 is 7. 7 is greater than 5. That's true. So what we have here for our solution is a compound inequality with or. Okay? So we can basically say that our solution is that x is greater than 5, or, remember our keyword or, x is less than negative 5. So we could also notate this in interval notation, right? It would be the union of the two solution sets. So I would have from negative infinity out to but not including negative 5. And then the union with, you have anything larger than 5. So a parenthesis next to 5, again, out to positive infinity. Okay, notice how I used a parenthesis with each, with negative 5 and 5, because they're not included. All right, so let's look at a general rule that we can follow when we're solving these guys. And this first rule I'm going to give you is just the simplest case scenario. We'll look at a different rule in a minute that will cover more challenging problems. So we saw that the absolute value of x is greater than 5 led to x is greater than 5 or x is less than negative 5. So in general, the absolute value of x is greater than k, so this is a greater than case, where we say that k is greater than 0. Okay, this has to be the case to use this rule. Then what's going to happen is we set up a compound inequality with or. So x can be greater than k, or you could say the negative of x, because the absolute value will make that positive, is greater than k. Now, what happens here, when you see this in your textbook, what they do is they divide both sides by negative 1 so that it's solved for x. And so you're going to get that x is less than. Remember, if you divide by a negative, you've got to flip the direction of the inequality symbol. So a greater than becomes a less than. And then k over negative 1 is just negative k. So what we see is that x can be greater than k, or x can be less than negative k. Okay, so this is what you're going to see. And again, when we worked with this first example here, where we said that the absolute value of x is greater than 5, we got just this. X was greater than 5, or x was less than negative 5. Okay, so that's where that comes from. So if I gave you a problem, like let's say the absolute value of x is greater than 14, well then you can very quickly say that x is greater than 14, or x is less than negative 14. Okay. The first scenario, you just remove the absolute value bars. So in this case, it would just be x is greater than 14. The second scenario, you just think about it like this. Flip the direction of the inequality symbol, so my greater than becomes less than, and then change the sign of the number out here. So from 14, I get negative 14. So if you could just remember that, you flip the sign and then make the number negative, you're good to go. Okay, that's all you need to remember. So let's look at our rule when it's more complicated. So when we get more challenging problems, we're not going to always have the absolute value operation isolated to start. So we've got to get it in this format of the absolute value operation on one side and a number on the other, okay? Notice how I've said that k is greater than 0. Again, if it's 0 or less than that, we'll talk about those special cases at the end of the lesson. But I want to isolate this to where the absolute value of some expression ax plus b is greater than k. So this is going to set up to this expression, ax plus b is greater than k, or ax plus b is less than the negative of k. All right, so same process. For the first one, I just remove the absolute value bars. I copy what's there. It's very simple. For the second one, I remove the absolute value bars so the expression doesn't change. I flip the direction of the inequality symbol, so now it's a less than, and then I make that number negative. So instead of just k, it becomes negative k. All right, so let's look at an example. All right, so for this one, we have the absolute value of 2x plus 3 is greater than 17. So the first case is I just remove the absolute value bars. So I'll have 2x plus 3 is greater than 17. Then or, my second case, I remove the absolute value bars. So 2x plus 3. I flip the direction of the inequality symbol, so it's a less than, and then I make this number negative. So it's going to be a negative 17, okay? And if you have trouble remembering that, you can always just make the expression over here. You could always say it's the negative of this guy. So the negative of 2x plus 3 is greater than 17. When you divide both sides by negative 1, you're going to get it into that format. So this would flip, and this becomes negative. Okay, so that's another way you can kind of remember it. All right, so let's quickly solve these two inequalities. For this one, I would just subtract 3 away from each side. I would get 2x is greater than 17 minus 3 is 14. Divide both sides of the inequality by 2. I get x is greater than 7. Okay, over here, if I subtract 3 away from each side of the inequality, that cancels. I get 2x is less than negative 17 minus 3 is negative 20. Divide both sides by 2, and we're going to get that x is less than negative 10. Okay, so we got that x is greater than 7 or x is less than negative 10. So let's erase this. Okay, so let me put my or here. So you could write it like this as your solution. You can, of course, do interval notation. So from negative infinity up to but not including negative 10. So it's the union with, you've got not including 7, and then up to positive infinity. Okay, so negative 10 is not included, you've got a parenthesis there. 7 is not included, you've got a parenthesis there. Now graphically, on our number line, we can put a parenthesis at 7, and we can shade everything to the right. Okay, all that. And then in terms of x being less than negative 10, we don't have a notch for negative 10, but we can just make one real quick. So we'll say this is negative 10, and let me make that a little bit better. And then I'm just going to put a parenthesis there, and I'm going to shade everything to the left. All right, let's take a look at another one. So suppose we have 10 times the absolute value of negative 4x minus 5 plus 2 is greater than 72. So again, the idea here is to isolate the absolute value operation on one side, have a number on the other. So what I'm going to do is I'm just going to subtract 2 away from each side of the inequality to start. That cancels. You've got 10 times the absolute value of negative 4x minus 5. And this is going to be greater than 72 minus 2 is 70. So now, since 10 is multiplying this absolute value operation, I can just divide both sides of the inequality by 10. So that cancels. Now I've isolated the absolute value operation. I've got the absolute value of negative 4x minus 5 is going to be greater than 70 over 10 is 7. Okay, so let me erase this. All right, so we know our scenario here with a greater than. We want to remove the absolute value bars. So negative 4x minus 5 is greater than 7. Then or, we want to remove the absolute value bars. So negative 4x minus 5. We want to flip the direction of the inequality symbol. So this is less than. We want to make this negative. So this is negative 7. Okay, so let's solve our compound inequality. Let's add 5 to each side of the inequality. That cancels. You get that negative 4x is greater than 12. We divide both sides by negative 4. Remember, this has the flip. We divide it by a negative, so this is a less than now. So you've got x is less than. 12 over negative 4 is negative 3. Over here, if I add 5 to each side of the inequality, that cancels. You're going to get negative 4x is less than. Negative 7 plus 5 is going to be negative 2. We divide both sides by negative 4. Again, if I divide by a negative, I've got to flip that guy. So this becomes a greater than. So we have x is greater than. Negative 2 over negative 4 is positive 1/2. All right, let's erase everything. So we can write our solution as x is less than negative 3 or x is greater than 1/2. Again, in interval notation, you're coming from negative infinity up to but not including negative 3. So the union with, you don't include 1/2, but out to positive infinity, okay? So again, negative 3 and 1/2 are not included. You have a parenthesis next to each. So now graphically at negative 3, I'd put a parenthesis facing to the left, and I would just want to shade everything going to the left here. So all of that. And then at 1/2, which would be about right here, let's say, I'm going to say that's 1/2. I'm going to go ahead and put a parenthesis there. So let's put a parenthesis there. And again, let's just shade everything to the right. Okay, so that's my solution region. All right, now let's talk about the other scenario, which is when we have a less than. So if I had the absolute value of x is less than 5, I'm going to follow the same procedure, but I'm going to use an and compound inequality. So in other words, I'm going to remove the absolute value bars. So I'm going to say x is less than 5. Then I'm going to say and. Then the next one, I'm going to remove the absolute value bars. So I'm going to have x. I'm going to flip the direction of the inequality symbol. So this is greater than. I'm going to make the number negative. So this is a negative 5. So it's the exact same process, but we're using an and now, okay, because we're going to have a between. So x will be between negative 5 and 5. You could really write this as a three-part inequality and say that negative 5 is less than x, which is less than 5. or you can read that as x is greater than -5 and less than 5. Now, conceptually, why does this make sense? I'm asking for all the numbers whose absolute value or whose distance from 0 is less than 5. Again, if I started at 0 and I went 5 units to the right, I couldn't be 5 because it's got to be less than 5. So I'd put a parenthesis there facing to the left. If I started at 0 and went the other way, again, I'd go 5 units. It couldn't be -5, but it could be anything greater there. So it would have to be between -5 and 5 on the number line. Those are the only values that would satisfy this. If I plugged in a -2, the absolute value of -2 is 2. 2 is less than 5. That works. If I took something outside of the range, let's say I took 6. The absolute value of 6 is 6. 6 is not less than 5. So it's got to be in that range of numbers to work and satisfy that inequality. If we see something more complex, we can just write down this rule. So I isolate my absolute value operation on one side. It's the same thing we saw with the greater than, but just now I'm going to have an and. So it's the exact same procedure. So the absolute value of ax plus b is less than k, where k is greater than 0. We say we have ax plus b is greater than -k, and ax plus b is less than +k. So again, the first scenario, just remove the absolute value bars. So that's this here. The second scenario, remove the absolute value bars, flip the direction of the inequality symbol, so you get a greater than, and then make this number out here negative, okay? The only difference is you're using an and statement. So really, if you want to make this easier on yourself, just write it as a 3-part inequality. So the expression goes in the middle, and it's greater than the negative of this, and it's less than the positive of this. All right, let's take a look at an example. So suppose we had the absolute value of 8x plus 4, and this is less than or equal to 52. Well, this guy's already isolated for me, so I don't have a whole lot of work here. All I've got to do is follow my rule. So I'm going to drop my absolute value bars. I'll have 8x plus 4 is less than or equal to 52. Then and, okay, I'm going to drop my absolute value bars. So 8x plus 4, flip the sign, so this becomes a greater than or equal to, make 52 negative. So it's -52. Now, I would advise when you solve these to put it as a 3-part inequality because it's just easier to work with. So I'm going to put that -52 is less than or equal to 8x plus 4, which is less than or equal to the number 52. So if I want to solve for x in the middle, I would subtract 4 away from each part. Let me scroll down and get some room going. So on the right-hand side, 52 minus 4 is 48. And then this cancels, so I've just got 8x in the middle. On the left-hand side, -52 minus 4 is -56. All right, so to get x isolated in the middle, I'm going to divide each part by 8. Let me make that a little better. So -56 divided by 8 is -7. This is less than or equal to, 8 over 8 is 1, so we just have x here in the middle. This is less than or equal to, 48 over 8 is 6. So I have that x is basically between -7 and 6, and -7 and 6 are both included here because we have non-strict inequalities. So let me erase all this. And again, we could write this in interval notation. We can use a bracket here at -7 and then a bracket at 6 to show these are both included. On the number line, I can use a similar process. So at -7, I put a bracket. At 6, I'm going to put a bracket. And let me make that a little better. And again, I'm just going to shade everything between here. So from -7 to 6, all those numbers work, including -7 and 6. All right, let's look at another one. So we have 6 times the absolute value of -3x plus 9, then plus 4 is less than or equal to 94. So again, I've got to isolate my absolute value operation so I can use my little rule. So I'm going to subtract 4 away from each side of the inequality. That cancels. I've got 6 times the absolute value of -3x plus 9. This is less than or equal to 94 minus 4 is 90. So now I'm going to divide both sides by 6 because that's what's multiplying this absolute value operation. So let me get some room here. This cancels. We'll have the absolute value of -3x plus 9 is less than or equal to 90 over 6 is 15. Okay, let me get a little bit more room. So now we're ready to set up our compound inequality with and. So again, first scenario, just remove the absolute value bars. So -3x plus 9 is less than or equal to 15. Then and, okay, you've got -3x plus 9. Again, remove the absolute value bars, flip the sign, so it's a greater than or equal to, make this negative. So this is -15. And again, it's easier to just write this as a three-part inequality. Just makes it faster to solve. So negative 15 is less than or equal to negative 3x plus 9, which is less than or equal to 15. All right, let's solve this guy. So we're going to subtract 9 away from each part here. Negative 15 minus 9 is going to be negative 24. This is less than or equal to, you've got your negative 3x here, and this cancels. Then this is less than or equal to, 15 minus 9 is 6. All right, so to get x by itself, let's divide each part by negative 3. And remember, even though it's a three-part inequality, we've still got to flip these signs. Very important you do that, okay? Otherwise, you will get the wrong answer. So x is going to be in the middle by itself. I'm going to flip the signs to greater than or equal to. Negative 24 over negative 3 is positive 8, and 6 over negative 3 is negative 2. So I'm just going to reorder this and say this is x is greater than or equal to negative 2, and it's less than or equal to 8. So let's erase everything. All right, so let's go ahead and write this in interval notation. Again, our endpoints are included here, so I'll put a bracket and then a negative 2, and then I'll put 8 and then a bracket. Okay, so this is interval notation. Again, negative 2 and 8 are both included, so we use our brackets. Then on my number line, I could put a bracket at negative 2 and a bracket at 8. I could just shade everything in between. So that's my solution region. Again, from negative 2 to 8 with negative 2 and 8 included. All right, now let's talk about the special case scenarios that come up. Basically, you have to think about things. If you get a right side of 0 or a negative, you have to think about what's going on, okay? If I get something like the absolute value of x is greater than or equal to 0, this is true for all real numbers, okay? So if you get the absolute value isolated on one side and it's greater than or equal to the number 0, it's true for every real number because the absolute value operation is either 0 or some positive amount. So if the result from your operation is 0, you're okay, right? It works. If it's some negative, it still works, right? Because you're going to get a positive. If it's positive, it still works. So every real number would be greater than or equal to 0 when it's run through the absolute value operation. So this is all real numbers, okay, for an answer. For the absolute value of x is greater than or equal to negative 5, again, absolute value is always non-negative. So it's always going to be 0 or higher, and it's always going to be greater than the number negative 5, right? It'll never be equal to it, but if it's a negative value, it'll always be greater than that. So this is also true for all real numbers. Okay, so if you see a negative over here and you've got a greater than, all real numbers is your solution. All right, what if you've got a less than and a negative over here? Well, here you can't get a solution, right? The absolute value of x is less than negative 5. That's not possible, okay? It can never be less than a negative. It can't be less than 0, okay? It can be 0 or positive. That's it. So for this guy, there's no solution, okay? Now, this one's a tricky one, okay? What if you saw the absolute value of x is less than or equal to 0? Well, we know that it can't be less than 0, but it can be equal to 0. So this one will have one solution. You basically need to set x equal to 0, and that's your solution. If x equals 0 here, that works, right? The absolute value of 0 is less than or equal to 0, right? 0 is less than or equal to 0. That is true, okay? But if I use any other number, it does not work, okay? So what I want to do with this type of scenario, if I've isolated the absolute value operation and it's less than or equal to 0, I just set that expression inside the absolute value bars equal to 0, and I solve, and that's going to be my solution. All right, let's look at a few examples. So we have negative 7 times the absolute value of 10x plus 4 plus 1 is less than or equal to 43. So again, we want to start by isolating the absolute value operation. So I'm going to subtract 1 away from each side of the inequality. That's going to cancel. I've got negative 7 times the absolute value of 10x plus 4, again, is less than or equal to 43 minus 1 is 42. All right, let's get some room going. So now I'm going to divide both sides of the inequality by negative 7. This cancels. I'm going to have the absolute value of 10x plus 4. Now I divided by a negative, so this has got to get flipped. So it's going to become a greater than or equal to 42 over negative 7 is negative 6. Now, you can stop here. The absolute value operation is isolated, and it's greater than a negative value. What did we say about that? The absolute value operation is always going to be 0 or some positive amount. So it will always be greater than -6. So this is true for all real numbers. So you can stop and say all real numbers. In interval notation, you can put from -infinity to +infinity. And if you wanted to show this on a number line, you could basically just shade the entire number line. Okay? This would be your graphical solution. Just shade the entire thing. All right, let's take a look at another one. So suppose we had -4 times the absolute value of 6x minus 8, then -6 is greater than 98. So again, I want to isolate this part right here first. Very important you do that. So let's add 6 to both sides of the inequality. That cancels. You've got -4 times the absolute value of 6x minus 8. And this is greater than 98 plus 6 is 104. Let's divide both sides by -4. So we know this cancels. I've got the absolute value of 6x minus 8. This is going to get flipped, so it'll become a less than. Then 104 over -4 is -26. Now, can the absolute value of something ever be less than -26? No, it cannot. Again, it's got to be 0 or some positive amount. So it doesn't matter what I plug in here for x. Whatever this result here is inside the absolute value bars, once I take the absolute value, it's going to be 0 or positive. So it can never, ever, ever be less than -26. So there's no solution here. No solution. Okay? And again, you can put that symbol for the null or empty set. All right, let's take a look at one more. So we have 4 times the absolute value of 8x minus 2 is less than or equal to 0. So again, I can divide both sides by 4 so that I can isolate the absolute value operation. So this cancels. I get that the absolute value of 8x minus 2 is less than or equal to 0 over 4 is 0. Now, the only way, again, that this works is if we set this expression here, 8x minus 2 equal to 0. Because it can never be less than 0. That's not ever going to work, right? Because once we take the absolute value, it's going to be 0 or something positive. So we can get it to equal 0, but we can never get it to be less than 0. So there's only one solution here. So 8x minus 2 is equal to 0. Add 2 to each side of the equation. You'll have 8x is equal to 2. We're going to divide both sides by 8. And we're going to get that x is equal to 2 over 8 is 1 over 4, okay, or 1/4. So the only way to make this true is if x is 1/4. This is not a range of values. If we looked at this on the number line, you would basically just go to 1/4. Let's say this is 1/4 here, and you would basically just put a dot there and say my solution is just that number.